Hi, my name is Ming. I'm one of the founders of Horologic Ming. Today, it's my great pleasure to present to you something that we've been working on for the better part of the last 3 years. We've hinted at it, we've teased it. Some of you might have seen various little bits and pieces of it, but the reality is, it's only now that it's finally ready for presentation. It was a lot more challenging than we expected. And we make no secret of this, but we do want to say that we've taken a lot of time and effort to really get this right. I am, of course, talking about the lightweight, the ultralight. What is probably going to be the world's lightest mechanical watch in two configurations, automatic and hand-wound. Both configurations, I think, will manage to take that honor. And today what I'd like to do is, for those of you who can't attend our presentations in person, I'd like to talk through a little bit about the philosophy of why we created it, how we created it, and some of the technical highlights behind the watch itself. And of course, I do have a PCO with me. We'll look at that in a little bit more detail later. I wouldn't say that it's easy to create something that's very light and very reductionist, but I will say that there are certain constraints that we've put into place on ourselves just because these are expectations that we have of what a watch should be. So for instance, this watch is made of metal. It has a fairly conventional movement, albeit heavily modified, but still a fairly conventional movement that doesn't use any exotic materials. It's a wearable size, and it feels like a watch. It doesn't feel like something that perhaps is not of a traditional design genre. So on the whole, we've created something that fits in our traditional design, together with our modern design language, our current design language, that feels like a watch, but then at the same time pushes the boundaries of engineering. Now, the way we've done that is we've started with the lightest material that we could find, and then it turns out that it didn't work. So we actually had to test 6 or 7 other similar materials in the same genre, both for corrosion, for durability, for biocompatibility, all of those things. We've settled on an AZ31 magnesium alloy that's based on magnesium, of course, aluminium. There is some nickel, there's some iron, and there's a few other things in there to make it machinable and stable. Now, on top of that, there is a plasma electrolytic coating, which basically gives it chemical neutrality. It makes it biocompatible, and it prevents oxidation. Furthermore, on top of that, we have a final coating layer, which at this point is being finalized between epoxy and diamond-like coating to give it further environmental resistance. Now, taking all of this into account is not enough. Just using a low-density material isn't actually enough to make a watch that's extremely light. We've also selected a movement that's fairly small. It's already fairly light to begin with, and that is the ETA 2000 as a base. We've removed components. We've lightened components, and these are new old stock movements that we've reworked. And then on top of that, basically, we've taken conventional watch construction and thrown it out of the window. So instead of having your traditional 3-piece case, where the case body holds the watch, the movement rather, there's a dial on top of that, and then you have a bezel and a case back, we actually have the case body and the dial basically holds the movement. It's like a hat. And effectively, we have the movement in the middle, we have the case body around the outside that forms the back of the dial, we have a bezel, we have a case back, but the case back itself is a skeletonized structure with flying buttresses to provide rigidity for the case body in the center. Now, what we've done is we've removed absolutely as much material as possible from all of these elements so that in places, the case body / dial is only 0.4 millimeter thick. It has buttresses for stiffness. The rear buttresses match up with the buttresses in the case body. Those are between 0.6 and 0.8 of a millimeter thick, with a 0.1 to 0.15 of a millimeter chamfer on all edges. That's both to reduce sharpness, but also it reduces weight by, I think, about 100 micrograms. The bezel is actually hollow as well, and we would have used a magnesium crown, except we have some threading issues and compatibility with the steel crown stem, so we had to use aluminium, so unfortunately we gave up a couple of grams there. Finally, the crystal is not actually traditional sapphire crystal, but it's Gorilla Glass 6, which has almost the same hardness rating, but has the benefit of being about 1/3 of the density. So to get this ready in time for our New York events has actually been a little bit of a challenge. So we have one cosmetically final prototype, a couple of functional prototypes, and the cosmetically final prototype represents the finish of the final watch. It is dark colored, and that's because we need the case body and all of the other elements to match. You can see the buttressing on the case back here, and of course you can see that we've got an interesting feature in the center of the dial. Now, the interesting feature in the center of the dial serves two functions. One, it's actually a gradient print on the underside of the crystal. This is to hide the movement underneath, because we don't have a conventional dial. That's to save weight. It also hosts an interference pattern. So there's a positive pattern on the disc, and then there's a negative pattern on the top of the crystal. And basically, that has a very nice running effect so that we can tell the watch is actually working. The thing is, there's a little bit of cognitive dissonance with this piece because it seems so light that it's almost impossible that there can be a movement inside. And this is the reason why we chose to create a dynamic running indicator, just to show that, or reassure the wearer that there's actually something going on. Plus, it's actually an interesting dynamic feature that we haven't used yet. This is, of course, is in addition to the automatic movement having a little resonance itself when you move the watch around. You'll notice that for the first time we actually don't have spring bars, and this is because spring bars are actually heavier than continuing to make a one-piece case out of the same magnesium. This has the benefit of actually helping with structural rigidity of the overall case. Structural rigidity of this case is actually quite similar to the 1709. Also, it facilitates the use of a lightweight strap design, which we'll supply in 3 different configurations together with the watch. One is a single piece Alcantara. We think of that as the record strap. It's very light. It's also very soft. Our preference is actually the double layer Alcantara, which has some color contrast to it, and at the same time is a little bit more rigid. And we also have a rubber for more extreme condition use. Now, the strap, of course, works like a normal NATO strap. You thread it through one side, thread out the other side. So we have a very simple hook buckle that actually works in 2 ways. You can hook it in from the top, and it engages with 2 of the holes this way. Alternatively, you can actually turn it upside down, and you can hook it in from the bottom this way. And once it's hooked in, you tuck the excess strap inside, and basically it works like one of our tuck buckles. This is for extra security should you desire it. As we've said before, we're making the ultralight in 2 versions. There is a hand-wind version and an automatic version. The price for both will be the same, availability will be roughly the same, and we're making 100 of each. Now, the choice is up to you whether you want the ultimate lightest watch or whether you want something a little bit more practical. We couldn't decide, so we decided to offer both options. The one thing I haven't spoken about is the absolute weight of the watch and the strap, and I guess the rest of the ecosystem. The headline number for the watch head for the automatic version is 10.8 grams. It may be slightly more, it may be slightly less, because no 2 movements are identical, so we've seen fluctuations of plus minus about 50 micrograms. The lightest movements that we've seen, or lightest complete watch prototypes that we've seen, have actually come in at about 10.65, and the heaviest have been about 10.7-ish. So we're being conservative on the weight here, and the same goes for the manual version, which is 8.8 grams. So this is a watch which is effectively the weight of 2 A4 pieces of paper. Now, the strap itself, at least in the record configuration, is similarly light. It's just 1.2 grams, the buckle being a further 0.6 of a gram. So all in all, you're looking at a watch that effectively feels the same as wearing a paper wristband. It's a very surreal feeling. It's like it's not really there, but then at the same time, if you have the automatic version, you move around, you feel it moving. Both versions have the thermal properties of metal, so you can feel that they're a little bit cold. And of course, you do have the running indicator and the pulsating star in the middle. Now, what I do want to say is that Personally, for me, this has been one of the biggest challenges that we've faced to try and make this watch a reality, because we've had machining challenges, we've had material challenges, even we've actually had design challenges as well, because this has now been through 3 design iterations through its lifetime, because we've changed the design language, evolved the design language as the material testing took longer and longer. But we're finally pleased to be able to offer this watch as part of the Special Projects Cave, and once again, thank you for your support. We're always available at MING.watch.